Okay, we're in lesson 4 now of the scale factor and similarity unit in Math 9. We're taking a little bit of a change here and we're looking at a specific shape today. We're going to talk about triangles and specifically about similar triangles. So similar triangles are essentially like scaled versions of each other. So they are the exact same shape, they have the same angles, but they just, their sides are all multiplied by a scale factor. So the formal definition, we'll write it down here, they have equal corresponding angles. So in the picture, for example, this 50 corresponds with this 50 and they're equal. They're the exact same angle. 63 is 63. And then this one would also be the same as well. Okay, and then they have proportional sides. What it means by proportional is they've just been multiplied by a scale factor. So just looking at this diagram here, let's look at the side lengths. So this one has a side length of 14 and this one has a side length of 7. It's been multiplied by 2, right? And same for every single side. They're all going to be multiplied by the same scale factor. So this side length here, 6 multiplied by 2 makes 12. 4 multiplied by 2 makes 8. So the larger triangle is twice as big as the smaller triangle, and they are similar. They have the same angles. They're the exact same shape. You have to have the same scale factor for every single side length in order for the triangles to be similar. All right, let's do some examples and find some missing lengths on some of these triangles. Okay. It says find the missing side lengths or angle using similar triangles. Determine the side length x and the measurement of angle A and angle B. Okay, let's talk about the angles first. Let's kind of split our page here. Okay, so these are both right triangles. We know that because of this square here. So a right angle is 90 degrees. There is a fact about triangles that you may or may not know, that when you have two triangles, all the angles add up to 180 degrees. So angle A here, you can write this, angle A is equal to 180 degrees minus 90 degrees, and looking at the blue triangle, minus 31 degrees, and that is going to give us 59 degrees. Because that's corresponding to this one here as well, so this is the larger triangle. They are similar. Angle B would also be 59 degrees. Okay, so the two triangles I'm looking at are the blue one and the yellow one. Okay, now to find the side lengths, a little bit more tricky. We need to set up a proportion. So what we know is that so I'm going to say side x. Use a proportion. So what we know is that the base, this length of the large triangle divided by the base of the small triangle is going to have the same scale factor as if I look at the heights. Height of the large triangle and then the height of the small triangle. Right, so if we divide the base of the big one by the base of the small one, we should get the same scale factor if we compare the two heights. We know the base of the large triangle is 10 centimeters. The base of the small triangle is 6 centimeters. The height of the large triangle is 6 centimeters. And the height of the blue triangle, we don't know. So we can solve this using cross multiplication. So we multiply the two numbers that are across from each other. and we divide by the number that's across from x, and we get 3.6. So you want to set up a proportion where you're comparing the lengths, and we know that because these triangles are similar, the ratios of their lengths will be the same, or the scale factors will be the same. All right, let's do a question where we don't know if two triangles are similar and we're trying to figure out if they are or not. So what we're going to do is just figure out if the scale factors are the same for all the corresponding sides. So these are the corresponding sides we need to look at. And so we're going to see if the ratios of those sides are all the same. So let's start with the yellow ones. 21 centimeters divided by 3.5 centimeters. We see we get 6. Okay, let's do the pink sides. 19.5 divided by 3.25. We also get 6. Okay, so far so good, looking like it might be similar. And then lastly, 15 centimeters in blue divided by 2.5 centimeters. We also get 6. So because the scale factor seems to be 6, the larger triangle is 6 times larger than the small triangle, even though these diagrams are not drawn not drawn to scale. The triangles are similar. Okay, great. And lastly, we have sort of an application question, real life question. Shadows involve similar triangles. So we can use the shadows of certain objects to figure out the heights or the shadow lengths of other objects. So let's see what we've got here. So it says a flagpole casts a shadow that is 12 meters long. Let's draw that. So here's a flagpole. Its shadow is 12 meters long. Actually, I should draw the shadow a bit longer than the pole. 1 second. I should draw it like this. Okay, so here's the shadow on the ground, right? The sun would be up here shining, creating this shadow. Okay, and at the same time we have this person and we want to know how long the person's shadow is. Okay, so we have this 12-meter long shadow here, and we have a person that is 4.8, has a 4.8 meter long shadow. We know the height of the person is 2. We don't know the height of this really tall thing, which is the pole. So we're going to determine the height of the pole. So this is a useful thing to be able to do, especially if you have the height of something that's hard to measure, right? We can use similar triangles to get it. So we have the larger triangle shown in yellow here, and we'll use blue for the smaller triangle, right? And we're going to set up a proportion to solve it. So we know that the base of the yellow triangle divided by the base of the small triangle is going to be equal to the same scale factor as if I compare the heights. The height of the yellow triangle divided by the height of the blue triangle. Okay, so let's fill in the numbers that we know. The base of the yellow triangle is 12 meters. The base of the blue triangle is 4.8 meters. Height of the yellow triangle, I don't know, and the height of the blue triangle is 2. So we use cross multiplication. We multiply the two numbers that are diagonally across from one another. 2 times 12, and we divide by the number that's across from x, and we get 5. So the flagpole is 5 meters tall. All right, and that's the end of the lesson.